Good morning, ladies, gentlemen, and fellow Earthlings. It's our pleasure to welcome you to another edition of the Space Times podcast. As always, I'm Paul Mayer here with Harrison Lambert, and we're excited to talk about some of the biggest news items in the industry from the past week.
All right, Paul, we got some cool news this week, mostly having to do with lunar missions, which is kind of new for us, and space structures, which have come up a few times. And of course, the ever-expanding list of space defense activities. There's been quite a bit of movement there this week. But to start off, I want to talk about lunar missions, because it is relatively unique. We have talked about it in the past. You know, there is a race to the moon, part 2, Electric Boogaloo. China is competing with America to try to land on the moon first, with the Chang'e landers being the most recent success. Although Russia's still in the mix too with the Luna landers that they build. But really, it's U.S. versus China, and a lot of that on the U.S. side has come to contracts for lunar landers and things like the Artemis mission for the lunar orbiting platform. And SpaceX has been on the contract for a portion of that Artemis mission, the lunar lander section, for quite a while. Now they are providing Starship as a lunar lander option for the Artemis mission, although that's alongside some other competitors like the large Blue Origin company that had a similar contract update recently for the Blue Moon Mark 1 lander. So there's some competition there, but SpaceX has had kind of unique hold on their portion of the Artemis mission, since there's nothing really competing with Starship at that scale or that capability. But their update this week has been that there's been some slips to deadlines. They're not, following exactly the schedule that was laid out with NASA, which, it's to be expected. Starship is way out there at the state of the art. They only completed their launches, or they only successfully completed a launch last week with a touchdown in the Indian Ocean in Texas, proving that both parts of Starship work. But now they're moving on to the next version of Starship. So we'd expect to see some more time spent developing just the launch capability, getting it to orbit. But they're already talking about demonstrating the in-orbit fuel transfer portion of this system next year, which is one of the big hurdles left for them to kind of meet that NASA contract. But that requires them launching multiple Starships and having them in orbit capable of docking and transferring cryogenic fuel, which boils off in space environment. So there's a lot of challenges there for them to still overcome. And they're not alone in having these kind of delays towards the return to the moon. SLS is having similar troubles, and we've been seeing a lot of talk about Orion exploring other launch vehicles to mount to. So it looks like overall the U.S. space industry is hitting a difficult time with a lot of the technology, and they're starting to reassess the timeline that they're expected to implement a lot of this. So it'll be interesting to see how that plays out against the Chinese advancements.
Yeah, a lot of the difficulties with on-orbit refueling and past even geo-orbit refueling and fuel storage is the sheer difficulty of keeping liquid fuel viable. So we'd spoken about this previously, that basically you can have a liquid fuel launch provider or a liquid fuel source of propulsion. You can have solid fuel source of propulsion or some form of hybrid mission. And effectively, the reason that we've never solved or done on-orbit fuel storage and on-orbit ignition for the most part, we've never really done that, is just because the difficulties of keeping that liquid fuel from boiling off, from keeping the cryogenic fuel source from evaporating and completely disappearing, those are really hard. And we spoke briefly about the solid state rockets and solid state fuel not being really great at starting or stopping. Sort of a once you start, once you pop, the fun don't stop. So getting a solid rocket or a solid booster in orbit for future use is it's a tough physics problem to solve. That's just a lot of mass that you need to get up to elevation and to altitude there. So to your point, yeah, it's fun to see all of this private and commercial innovation trying to solve these problems that really we haven't needed to solve, except for the very bespoke solutions and getting people to and from the moon back in the 60s and the early 70s. So very interesting to see the growth and the innovation that's happening now. If memory serves, I think there were a series of lawsuits alleging anti-competitive practices and favoritism, effectively, between Blue Origin and SpaceX. I think they were regarding the lunar lander contract that SpaceX won directly. And I think the claim from Blue Origin was that because the lunar lander that SpaceX was building was dependent on the success of Starship 1, their claim amounted to that the being awarded the contract for SpaceX being awarded the contract for the lunar lander or the lunar transport vehicle amounted to an anti-competitive practice because it was predicated on the success of Starship, which amounted to the U.S. government sort of subsidizing Starship with that contract, which was argued to be fundamentally non-competitive. So it's a tough bind for people to truly make sure that this is the sort of above board competitive practice that everybody wants to see, especially because Starship is at this stage really fundamentally necessary for continued space exploration and for continued space innovation on these larger scales. And so, it'll be interesting to see how SpaceX winds up winning future contracts and whether or not some of the other lunar transport vehicles and other, I'll say, layers of the lunar exploration chain here wind up being able to win some of the government contracts necessary to do that, or whether it winds up all or in large part going to SpaceX because SpaceX has the launch capability themselves in order to get everybody there.
Yeah, I find it really frustrating with SpaceX and Blue Origin kind of competing on this front, because it's one of those areas where it's not really a technology that we're building for their own commercial use. It's a capability that's really useful for the nation. Like having lunar landers and lunar rovers is not really going to help them commercially in any short-term perspective. Maybe when we talk about lunar bases and applications thereof, it might make more sense. But right now, it really makes more sense for them to be working together, since our real competitors are China and Russia. And whoever gets there first has a real stake in claiming, some of that land and taking ownership of certain rights, even though it's outlawed by space treaties. There's been quite, plenty of expression from other nations to not respect those treaties. So it's really important that we pool all of our resources to kind of get there first. And there's plenty of competition across other smaller companies for lunar landers that can kind of keep that aspect alive without kind of challenging these larger contracts between SpaceX and Blue Origin and Dynetics. We've seen quite a few landers attempt to make it to the moon in the past year or so. Intuitive Machines, Astrobotic, iSpace, they've all made attempts to various success. But they're all contributing to the technology needed to make this a more standard practice. And refueling is definitely a big part of that. Getting from Earth to the moon is not that easy with most launch vehicles, and it would really open up the launch vehicle. It would really expand the launch vehicles that are able to get us to the moon if we are able to figure out on-orbit refueling. So I would expect SpaceX solving this problem is going to be very specific to Starship and doesn't actually solve the problem for other customers that might be trying to get to the moon. So it's good to see that companies like iSpace have started looking into refueling and recharging for lunar landers. They're partnering with Orbit Aid, which is an Indian company, to start developing technology for that. And this is something we've seen in a couple other places in the past weeks. Orbit Fab is also kind of dedicated to on-orbit refueling. I haven't heard any news about them recently, but that's what they're focused on. So that's a great capability to build for the industry. And more recently, though, we've seen that Rocket Lab has finished the satellite for ETA Space to test out cryogenic fueling on orbit. So that's a little more progress in that area. And I hope to see any of those companies demonstrate the capability to do that on-orbit refueling, because as you said, it's really hard. There's a lot of problems trying to transport fuel in space, especially the high-efficiency cryogenic fuel that really likes to kind of escape from containers, especially when it's being transferred between two of them in low-pressure environments.
Right.
Intuitive Machines, like I mentioned, another company working on landers. They've got an $8 million contract extension from the United States Air Force Research Laboratory to continue work on nuclear power in space. So good to hear they've already been working on it. That would be a good technology as well. Not really in the Artemis scope of things, and not really something SpaceX or Blue Origin are looking at yet. But I like to hear any kind of work towards nuclear power in space. It's been a long time since anybody's been able to use it, and at this point, it's just the U.S. government. So, besides just the fact that the technology is being worked on, it's nice to see that the U.S. government is indicating their intention to use nuclear power again for more applications.
Right. I mean, back to the refueling and recharging for the LTV ecosystem. We spoke about this previously, but there's an ecosystem of startups that are building out the capability to demonstrate space-based interceptors, more specifically space-to-space based interceptors rather than space to Earth or terrestrial based interception. And the key problem that they are solving in order to provide that capability is the on-orbit cryogenic storage of these fuels that we've been discussing. So I would not at all be surprised to see in the next 18 months, in the next 2 years or so, as people are building and where there's a concentrated effort on in-orbit and on at altitude refueling and recharging of these space-based vehicles, I would not at all be surprised to see one or more of these space-based interceptor startups get bought up and get acquired explicitly for their proprietary tech stack that allows them to keep this fuel at temperature stably. So really interesting stuff there. And to your point, yeah, one of the biggest challenges that was echoed at the Payload Lunar and Mars Economy Summit was the need for power at site, the need for power both on orbit and in situ. And so nuclear power is largely viewed as one of the best options, one of the best solutions that on paper checks all the boxes that we need. And the difficulties in getting to those on paper solutions are numerous and difficult. There's a lot of these problems, and none of them are easy. But it's great to see Intuitive Machines making progress and working with the Air Force Research Lab to try and bridge some of that gap.
Yeah, it's interesting you bring the space-based interceptors again, because Apex explains that their concept uses solid boosters for their missiles or their interceptors. I'm not a huge fan of that. Traditionally, solid boosters aren't used in orbit because they kick out debris as they burn, which is not great for cluttering up space, and it's not even great for the satellites they're launching from. So it seems very odd that they would go with solid boosters. It makes sense. They're easier to store. They're cheaper. They're faster if you're trying to intercept a missile. But if somebody can figure out the storage of liquid propellant, then suddenly a hybrid or a bipropellant rocket makes a lot more sense on orbit. They don't have to keep them fueled. They can fuel them on demand and launch them as needed.
Yeah, it's a fun space. It's one that we should keep an eye on and stay informed on.
Yeah, and I mean the technology that kind of goes hand in hand with this is fuel depots on orbit, and I think that would plug in a lot to those kind of missile defense systems that are being built up, and hopefully towards some of these proliferated networks. Since we're seeing that Starlink is tens of thousands of satellites, and they're dropping 2 satellites every day from orbit, which is some research has shown not great for our atmosphere. So if we can kind of get more towards space systems that are able to refuel in order to stay in orbit, in order to keep station keeping, that'd be a huge improvement to not just on orbit space environment and cluttering of debris, but also effects on Earth's atmosphere from deorbiting satellites. One of the companies that might be working on this is Space Quarters. It's a Tokyo-based startup that just raised $5 million in seed funding to develop construction systems for assembly of large orbital and lunar structures. This is something we've brought up recently with a few different companies. I think Momentus was the most recent with their large structure contract for like 5.1 million. There seems to be a growing need for large on-orbit structures, which in the past years I've mostly seen talked about for space habitats. So companies like VAST and Axiom building private space stations, which has always had kind of a more space tourism market use case, reasoning behind it. But I find these larger space structures to be a more interesting proposition, because they can do things such as build structures on orbit to reduce size and mass constraints on the launch vehicle. They can store fuel to refuel systems to keep them in orbit longer. They could be used as habitats, or as we're seeing more recently, they could be used as data centers.
Yeah, we spoke about this last week a little bit with the importance of sort of mirror satellites and the value that those can provide. That really sort of extends to the flat sat concept in general. Any satellite that can be designed that's basically a flat disk several inches thick that can go up on orbit. Any sort of on orbit assembly or construction project can be used to really easily and really cost effectively create a megastructure of dozens, if not hundreds, of these flat sats that give it access to a huge square area, square footage coverage. Lots of power, lots of solar energy coming in. Lots of radiative cooling, lots of dark side of the satellite going out. So it's a really easy way to theoretically build out a valuable data center with infinite free power and infinite free cooling. And so it's a really logical explanation, and it's a really logical next step for on orbit construction and assembly of different structures and vehicles. I think, to your point, we should expect to see the more commercial, more megastructures, or more efforts to build megastructures on orbit that serve commercial terrestrial interests, rather than focusing on space tourism, as the current power and data center needs for the AI boom are orders of magnitude bigger than any sort of any terrestrial or human rated tourism missions at the moment.
Yeah, the thing I really want to watch is if this technology can outpace some other already developed technology. So large on-orbit structure manufacturing is not very far along. Like I said, we've seen the past weeks more announcements about it. And there's a couple of companies that have probably already positioned themselves well to do this, but it's not really a part of any large governmental funding right now. The closest I can think of is like the Tiangong for China. And it's that this kind of large in-space manufacturing is integrated into their space plan, but not so much into the US's, or for that matter, EU. Most of the money nowadays is flowing towards proliferated communication networks, missile defense networks, space domain awareness, in orbit rendezvous proximity operations. none of that requires large space structures. So I really expect this technology to kind of lag as it has been. But the company that's most poised to achieve this kind of business proposition is actually SpaceX. And this last week, they announced their intention to do just that, to add space data center capabilities to Starlink. And the plan is to do that with Starlink V3. This is the improvement upon the current V2 Starlink, which will boost them up to 1 terabyte per second downlink rate, which is crazy. Like, it's super high. It's on the order of geostationary satellites, like Viasat's launching next week with a Geocom satellite that's been in development for years that has the same downlink rate capability. So these Starlink terminals are very capable of the communication aspect, and bolting on the compute needed to turn them into data centers is a fairly reasonable expansion of their platform. And this platform, like you said, is implementing kind of that flat pack design that Starlink always had, but the design looks a lot like it's anticipating Starship being ready. V3 is not expected to launch until next year, and seeing as how Starship just succeeded in launching, it seems like the timing is perfect for a Starlink update to take advantage of the larger footprint of Starship, give it more space for more of that thermal exhaust and more of the power generation that we were talking about that's needed for these on-orbit compute platforms. And so they might be poised perfectly to kind of leverage their existing plans to beat everybody to the punch on these orbital data centers. It definitely lends credence to the business case, whereas most people have kind of laughed it off. Smaller companies are saying they're going to achieve, or they're going to strive for this. Larger companies like Blue Origin have said they want to strive for this. Relativity Space was a big one when Eric Schmidt took over as CEO. He announced his intention to turn that into a data center company, which makes sense being the former CEO of Google. But it seems like SpaceX is really beating everybody to the punch. It's just sad to see for StarCloud, since they just launched the NVIDIA HS100 last year, and looked like they're taking the lead in terms of actually making progress towards this. But I think SpaceX really has themselves in the great position to actually achieve this. I think where they might falter is long-term. Starlink network is not constructed to be a data center, so they might reach limits of how much data they can actually store and process on orbit if they're really trying to just leverage the existing architecture instead of creating a whole new fleet of Starlink platforms built specifically for on-orbit data processing.
That's fair. I actually disagree with you a little bit on this. I think it's great that Elon Musk and SpaceX have indicated that this is something that they intend to do and that they're going to do. And the reason I think it's great is that Musk and SpaceX have a history of sort of over-promising and then delivering a little bit of what they promise. So I think the failure points and the hurdles that you've identified, the fact that the Starlink network is not fundamentally built in order to be this major throughput, this major connection hub that they're sort of describing, that it's not fundamentally built up to be to support the total throughput necessary for data centers. I think it's great because one, it calls a lot of attention to the space. It highlights for a lot of the investors and capital sources in the industry that this is sort of a valid market. If Elon Musk and SpaceX are trying to solve this problem, it provides a lot of validity to the market that other startups and other players in the space may have also been propping up and selling as this major opportunity. So it validates the market fit, and it validates the opportunity a whole lot. But also, sort of to your point, SpaceX is positioned to do very well in the space. However, this represents a new capability for them. And so I think that there's plenty of opportunity, and there's still plenty of room for the folks who have been working on solving these problems, the folks who have already been doing this for the last several years, there's plenty of room for them to achieve a lot of success before SpaceX sort of catches up to their capabilities. So, you know, I don't necessarily view it as a SpaceX will automatically win out this market share. SpaceX will automatically win out the space data center market. And I view it more as a signal that this is something that SpaceX is going to do in the next 5 years, plus or minus, in the next so many years. So that gives everybody a reasonable and healthy timeline to get in there, win market share, and make a lot of revenues, and then maybe themselves be acquired by SpaceX when SpaceX realizes, like, okay, well, we'd have to solve this problem or that problem that we haven't yet solved yet, and it's more cost effective for us to acquire this, that, or the other startup that has solved that problem really optimally than it is for us to build that internally. So I'd offer a little bit of pushback on there, but we're in agreement. We're in agreement that this is a cool space for sure, and that the fact that SpaceX is indicating that this is a problem that they want to solve, that this is a market they want to win, it's definitely a good thing for the market overall.
Yeah, I like that they're usually a market leader and not just like a market dominator. Like when they launched Falcon 9, it changed the whole launch industry. You know, they've got all these smaller satellite companies that can operate. We're looking to see the same with Starship, with a change in how we can launch stuff. And Starlink has kind of already enabled a lot of functionality both on Earth and in space. And I think what I really look forward to is if Starlink really does enable this feature, we can start seeing not just applications on the ground, so sending stuff up to space to process. Cool, we can do that on the ground. This just has like business implications about savings and costs and all that. But what I'm more interested in is off the back of the news of Muon Space last week with their Placer communication terminal being able to plug directly into Starlink. It'd be really interesting to start seeing how Starlink can augment on-orbit assets. We might start seeing satellites that don't need as much compute on board. We've talked about companies like Starcatcher that want to beam power directly to a satellite. These kind of capabilities where we decentralize a lot of the functionality of each spacecraft would be really cool advances. I mean, it would bring down the cost of satellites. I really like the idea that we could launch newer payloads without all the additional cost of building up an over-designed bus. And we can start kind of keeping that to other networks that are persistent to provide communications and processing and even power. It could really change, how satellites are designed, how quickly we can get stuff up to orbit, how up to date things can stay from a technology standpoint. So it'll be really cool to see how that plays out. I think some other smaller companies are kind of seeing this same shift. Voyager, we've been talking about a lot recently. They had the partnership with Vivace on Starlab, which is a private space habitat, so meant to replace the vessel. And when they were talking about that, they look like a company that was focused on the same kind of large on-orbit structure with the primary application of commercial space habitation. They've since acquired a couple companies and made some statements that make it sound like that use case is not as much of a business fundamental to them as the more standard use cases that we're seeing more frequently, like missile defense. They, a few weeks ago, acquired Bridgecom, which was a very significant acquisition for their laser optical terminals, which is a key technology across proliferated communication networks, across missile defense networks. Just any modern network of satellites in orbit today is starting to use laser terminals. So this acquisition was huge. And just this week, they acquired Exoterra for their electric propulsion technology. This gives them some in-orbit mobility, which is another key facet of missile defense and these proliferated warfighter space architectures, Golden Dome, all of that. So it seems like a lot of the acquisitions they're taking in are positioning them amongst the competitors for all of this PWSA and Golden Dome funding.
Yeah, I mean, Voyager is one of the key partners involved with Starlab, and we've spoken about sort of the ISS in our Redshift article. We've spoken about the difficulty of replacing the ISS with a commercial space station, just because the research being done on these space stations is almost always academic in nature, and so finding a revenue generating, a net revenue positive cash flow generating model for operating one of these commercial space stations is a really hard model to create. It's a tough thing to set up properly, because candidly there's just not a whole lot of money in the university experiments that go up, right? But to your point, Voyager, and in their own press releases, Voyager Technologies has very much sort of echoed that sentiment, and that you conveyed. But they've very much been positioning themselves as a key defense player. They've very much been framing and setting themselves up to be one of the key competitors going after. I believe it was 24 billion in appropriations that were carved out for the Golden Dome initiative. So Voyager is very much setting themselves up for that. ExoTerra, they're citing ExoTerra's high efficiency Delta V propulsion systems as a major reason and a major solution for a major driver of value for on-orbit operations to avoid threats and sustain mission advantage. They're citing it as the capability to improve the resilience and survivability of on-orbit assets. The language that they're using is very much intended to position themselves stronger for the Golden Dome contract. So between acquiring the laser optical capabilities through Bridgecom and the on-orbit maneuverability and propulsion capabilities through ExoTerra, Voyager, who today is effectively a systems integrator, a systems engineering solution, they are positioning themselves well, and they're effectively following the Lockheed Martin model of being a systems integrator, being a systems engineering solution with multiple different subcontractors based therein. And Voyager is simply integrating those subcontractors and their capabilities into their product suite.
Yeah. I mean, when I looked at ExoTerra, like for electric propulsion, it made a lot of sense since it's so high efficiency, it made more sense for their Starlab. But honestly, like both of these could have dual use. If they can build a habitat, they can build other uses for it. So, they seem like really strategic acquisitions. I think Voyager is going to see a lot more momentum from the missile defense side of things, which makes sense given recent news, especially this week when SpaceX secured $2 billion in government contracts for missile tracking satellites under the Golden Dome initiative. These are some of the first contracts going out for Golden Dome. Mostly it's been all talk. But as you mentioned, there was $24 billion carved out by appropriations back in July. So the money's there, it's allocated. It just hasn't been handed out much. So this is a really big win for SpaceX. It's basically just an application of their Starlink satellites. It looks like they might create a new kind of sect of Starlink for what's called MilNet, military network. I can't imagine it's much different than Starship. Same kind of thing, taking a Starlink platform, designing it for military application, and providing it for military-only use. So this really just seems like a follow-on of that, maybe for some new applications, but it doesn't seem like there's much development needed on SpaceX's side to kind of achieve that. So big win for them. It's nice that it still leaves $22 billion laying around for other companies like Voyager to snatch up. And we've talked about plenty of companies that are definitely positioning themselves for that money as well. So really, really cool to see who else gets it. I imagine it will be distributed quite broadly. That if SpaceX only got $2 billion, I can't imagine what other company would get more than that. So hopefully a lot of promising small space startups are able to get a chunk of this and helps them towards development and deployment.
Yeah, it's interesting that the official the official first contract came out during a government shutdown, but that only highlights the magnitude of the problem, the how much of a priority Golden Dome is, and space defense is. It really highlights the premium and the priority that the U.S. government is putting on basically everything that we discussed regarding the Redshift article. This is clearly not going to be something that we're comfortable putting on the back burner or putting off until later. So it's great to see some of that appropriations bill starting to get allocated and starting to get into the hands of the builders and innovators necessary in order to provide the capabilities that we're looking for. Some additional big announcements in the defense sector are largely centered around actually contested communications. So Airbus and the Spanish Armed Forces have launched an anti-jam SATCOM constellation for secure communications, and we've seen a couple of different companies playing in this space. I mean, one of the ways that you can beat sort of jamming is by having a stronger signal. So you do that by increasing the power to the transponder itself, or by flying at a lower altitude so that the signal is stronger. I mean, this signal strength is proportional to the square of the distance. So if you cut the distance in half, you strengthen the signal by 4 times. So one of the ways you can get past jamming is just by juicing the power to that system by increasing the strength of the signal. Another solution is to broadcast the signal in a different frequency, so that the jammer isn't able to effectively jam that frequency. So you're able to transmit the data in a different spectrum or in a different wavelength than the jamming infrastructure is. Though generally speaking, that solution just means that you buy a jammer for that different frequency. And so the economic arbitrage of a jammer to an orbital asset is massive. So it'll be interesting to see how the most critical sort of defense contested communication solutions wind up solving the problem, such that the defender isn't spending $1 million so that the offender can spend $1,000 and wind up at the same outcome. But Airbus and the Spanish Armed Forces have worked together on that constellation that's going to be coming out. Kymeta won a contract with the US Army domestically to supply satellite terminals for tactical SATCOM, a similar solution providing an on-site direct communication network to the existing sort of satellite infrastructure on orbit. So it'll be interesting to see how Kymeta and Airbus wind up solving some of these problems and bringing more reliable communications to contested zones and contested regions. And finally, sort of Vantor won a U.S. Space Force award for space domain awareness of low Earth orbit blind spots, which what that amounts to is a combination of both upward and horizontal facing awareness. So space to space awareness and Earth to space awareness. So things are starting to get crowded, and the space domain awareness ecosystem and industry has known that this has been coming for a while. So this is a sort of a key milestone in that domain, that the U.S. Space Force is starting to award contracts specifically for solving these problems and providing that space domain awareness information.
Yeah, this one's really interesting because Vantor hasn't done this very often, and they started doing it last year, where they take pictures of other satellites from Worldview 2, and they're able to get really great detail out of these images, which gives more context than any other solution that we know of. to tracking other satellites, particularly foreign adversaries in kind of the space domain awareness arena. It's a really powerful capability. I mean, ground-based imagers, they can pick up the satellite, but it's more like a silhouette. I'm sure the Department of Defense has much higher resolution than they let on, but even then, you're looking through the atmosphere. Being able to look from space to another space asset is a much clearer picture. And this is with Worldview 2, so it wasn't even built for space-to-space imaging. It was space-to-Earth imager. So the fact that they're able to get additional useful information out of this imager, is great. It's further validated by this award from USSF. I'm hoping that it leads to new satellites that are specifically built for this. And I think Vantor is in a good spot to do that. And it's kind of included in some of the higher tranches of the PWSA, which I don't think any contracts have gone out for yet. But I would kind of expect this more to show up with Golden Dome. This capability is fairly unique. There's a lot of money there. I'm sure they can convince somebody to pay for this capability to either be further used just from their current on-orbit satellites or further developed from launching new ones and building them specifically for this use case.
So jumping into the lightning round here, there are a series of big updates that we want to hit on briefly in the time we have left. Denmark contributed roughly 420 million in funding for their space effort as an ESA contribution. So again, another piece of evidence and another point towards the continued increase in spending from Europe and European nations to their space-based defense capabilities. Additionally, Maritime Launch Services based out of Nova Scotia received a couple $1 million from Canada for spaceport improvements. So this is another example of the US and US allies wanting to onshore more space launch capability. So MLS is up in Nova Scotia, which means that we'll be looking almost exclusively at polar launches from there. But similar to Vandenberg Air Force Base, polar launches are perfectly good for everything that we want to put into sun synchronous or low Earth orbit. So it's great to see another potential launch site developing and coming along. Additionally, Karman, K-A-R-M-A-N, Space and Defense, added the subsystem supplier 5-axis to their portfolio. So recent acquisition, I believe it was $88 million in cash plus $5 million in common stock shares of Karman Technologies that sealed the deal. And in order to seal that deal, Karman extended their term loan B. So they had an existing loan out there for, I believe, $300 million or $350 million. They extended that loan by roughly $130 million. And with that money, they were able to conduct the acquisition of 5-axis for $88 million. And they also paid off their revolving credit loan, their credit revolver, so to speak. So interesting development there. But probably the biggest business development that we've got is the Rheinmetall ISI joint venture that Sat News just announced earlier this week. Effectively, Germany's army is buying 40 small low Earth orbit satellites to bolster their ISR and sovereign capabilities. It's a $3 billion purchase. So again, Germany is really bumping up and is really increasing their space capabilities and their space defense spend. And in so many ways, Germany's economic trends and position tends to signal the same for the rest of the EU. So we will probably see more examples of Denmark and other EU nations increasing their spend and donation to ESA to improve Europe's space defense and space capabilities more broadly. And finally, I
wanted to say, like, this is a big move for Germany because they had the $60 billion investment a few weeks ago. And this is even more money on top of that. So they're spending billions and billions of dollars on space technology, which is pretty huge. And even this week, they've announced that the Ariane 6 upper stage manufacturing and integration is going to be moved to Germany as well. It was previously at Avio's headquarters in Italy, which Avio we've talked about a lot recently as well. They've got a lot of great rocket technology, and they're working on reusability. So it's really interesting to see that they're moving some of that tech up to Germany. It seems like they're really centralizing a lot around Germany, and maybe that has to do with the funding, or maybe the funding has to do with that kind of refocus towards them. But it's really interesting to see because Germany doesn't have the strongest space industry out of the ESA partner countries. But we're seeing this across all these countries. Like you mentioned, Denmark is still ESA, contributing a fair share for their size, and Canada building up their first launch station. So their first spaceport for a while. They used to have the one in Manitoba till the 80s, but it turned into sounding rockets and then turned into nothing. And the only one they have left is this Nova Scotia one, which isn't really used for this. So they're spending this money to build it up. And InnoSpace out of South Korea is kind of going a similar route. They're preparing to launch their first orbital launch vehicle. So this would be Korea's first launch vehicle. And I think they're planning to do it out of Alcantara spaceport down in Brazil. So another cool thing to see, because they're not partnered with ESA, they're not partnered with the US, and they haven't, they've done some satellite work, but they haven't gotten a launch vehicle yet. So it'll be really interesting to see them launch vehicle. And I would expect the next thing they would do is start building their own spaceport, so they don't have to rely on Brazil.
Yeah, it makes perfect sense. I mean, this is the trend that we've seen. We've seen Japan increasing their space spending. We've seen Finland increase their space spending. We've seen a multitude of European nations increasing their space spending. This is the first I've heard of Korea getting into the space ecosystem themselves, but congratulations to them. We want to pat ourselves on the back briefly, but Bloomberg has released some reporting indicating that Globalstar is currently in a sales process and that SpaceX is sort of the key potential bidder that they're looking at. So just like we discussed last week, Apple is considering pulling out of their existing contract, and SpaceX is considering buying them up. So there's a lot of volatility in Globalstar's valuation at the moment. And it'll be interesting to see how that winds up playing out. SpaceX buying up Globalstar would basically amount to a major consolidation in the D2D market before the D2D market even fully materializes. So it'll be interesting to see from multiple perspectives how this winds up playing out, whether Globalstar does sell, whether SpaceX does end up buying them, or whether one of SpaceX's aspiring competitors in the D2D space tries to buy up that capability, and whether any of those movements or transitions affect Apple's looming contract. If Apple basically goes with just one provider for D2D communications, and they optimize their architecture and chipset for that, it's hard for that player in the space not to already be king made. The Android and non-iOS device network is much more fragmented than the Apple network is. So if you win over Apple, that's a pretty dominant market position right off the bat if you're the single source supplier for that.
Yeah, that's huge. The other thing we got right a while ago is the projection that Venus Aerospace would do well with their rotating detonation rocket engine. We kind of talked about it as a tech demonstration, but it seems that they're further along, or as far along as they say they are, because Lockheed Martin invested in them this week. They had a couple of interesting moves we talked about, like adding some people to their board and some tests of their engine. But this is a huge validation of their technology, and they're one of the few companies that are playing in this space. So, hopefully the money gets them a long way towards operationalization of this technology, because the rotating detonation rocket engine is not just cool, it's really, really useful. And it would improve not just our launch vehicle capabilities in terms of fuel efficiency and speed to orbit and all of that, but it's also very sought after for hypersonics missile technology. So expect to see it applied in both cases. Obviously, Lockheed would have probably more interest in the hypersonic missile space, but they do launch vehicles like through ULA. And I would expect to see something like General Electric start spending more money on their rotating detonation rocket engine, because they're really the only other ones in the space with a viable technology. Even in the same space, Kratos Defense has won a $68.3 million Department of Defense contract for thermal propulsion and hypersonic materials facility. So again, there's a lot of movement in the hypersonics kind of department, not just off of the RDRE, but other ramjet technology. We see it across multiple companies like Boom Aerospace is probably the one that's working on it the most in terms of the startup realm, but most big players in the defense industry have their own ramjet technology they're pursuing. A few other advancements across smaller companies this week, or a few advancements across companies this week related to nature tech. We've talked a bit recently about some environmental efforts through startups. And I found the ABB contract win from the Canadian Space Agency particularly interesting because it's for an infrared spectral imager that's going to model aerosol cloud interactions. This is a bit different than a lot of the radio occultation satellites that we've been talking about recently. This is honestly a bit more straightforward. Infrared's able to pick up a lot of refraction in the wavelength that water interacts with. So you can see things like water density in clouds, and I think you can even kind of slice through the cloud layers and see the volumetric density of the water. So you're able to get a lot of environment or a lot of weather information out of that. And so it's kind of it works well with radio occultation, like they're complementary systems. So it's just good to see more technology being contributed towards weather forecasting, especially after Tomorrow.io launched satellites today on Bandwagon 4, along with 18 other satellites, and they've successfully made it to orbit, which is awesome. iSci and EMIS, a Slovakian geospatial platform, are partnering on a SAR flood intelligence platform for disaster response, which I love to see. Disaster response is a great application, especially with that $3 billion from Germany going to iSci for their ISAR technology. Hopefully some of that can be recycled back onto some of these more altruistic disaster response applications. Space Cargo and COMAT are partnering on a microgravity platform for in-space manufacturing. This is cool to see because it's not very common. Vantor Space Systems is one of the only other companies that does it for pharmaceutical manufacturing on orbit. But the idea here is that a thermally regulated, fully integrated, autonomous on-orbit manufacturing facility would allow for us to grow certain things that can't be grown on Earth or can't be grown as well on Earth. And so that typically means pharmaceuticals with larger monocrystalline structures, which lead to better effectiveness and longer performance of the drug that gets manufactured in space has to be brought back down to Earth. So there's some limits on logistics there. The other applications that are commonly proposed are for silicon chips or solar arrays, since the larger crystal structure can lead to improved compute capability or improved solar efficiency. And those could be used in orbit or return to space or to Earth, but usually the application makes more sense for on-orbit manufacturing. And probably the coolest thing I heard this week was that Quantum Dynamic Enterprises has won a US patent for a propellantless propulsion system called the Centrifugal Impulse Drive. This was modeled by Dr. Shakib bin Hassan and independently tested by Georgia Institute of Technology, which is promising to hear, although it is not reassuring unconditionally, because most of the time when I hear about propellantless thrusters, it's for the EM drive, which is this idea that uses a giant copper kettle and they fire microwaves into it and it creates thrust from no propellant at all. The idea is that it just the electromagnetic frequency creates this kind of offset with the resonance, and that drives momentum. It was tested, throughout multiple universities and shown to work sometimes, and so it was never really proven that it works until somebody kind of realized, oh, it's just playing with the Earth's electromagnetic field. The the momentum that's being imparted on the spacecraft just has a counter force on the Earth. So it's not true. It's not true kind of one-way thrust. The big concern with that thruster is always it violated the conservation of momentum, which is pretty much what all of these propellantless thrusters violate. So they can't possibly be working. But the fact that they were able to test it and that it got a patent is very promising. The tech uses two rotating magnetic masses that are offset from the center of rotation and create vibrations that are out of phase with each other, and that apparently drives the linear motion from the thruster. But I could very easily see how this falls into the same category as the EM drive, where it's just these magnets interacting with the Earth's magnetic field and creating thrust there, which you can't really truly test if that's the case until you're outside of Earth's magnetic field. But it'll be cool to see if this one doesn't suffer the downfalls of the EM drive, which is it's too heavy for the thrust that it generates. If they can make this low mass enough and it creates thrust somehow, it would be awesome to have a propellantless thruster, because it would unlock so many applications in space and just make things have less debris. Satellites can have longer lifetimes. You can do a lot of interesting things that weren't previously possible.
Absolutely. I mean, I love a good perpetual motion machine as much as the next person. But I do think that, and at TechCrunch Disrupt, there was a company right next to us that was building something similar. Certainly not the same as the Centrifugal Impulse Drive, but a similar propellantless propulsion device that on first glance, it's not clear whether or not it satisfies conservation of momentum, but it does satisfy conservation of energy. So there's multiple people trying to provide a fuel-free source of propulsion and thrust on orbit. Granted, that thrust is going to be Granted, that thrust is going to be order of magnitude, I believe, millinewtons, not piconewtons or micronewtons, but millinewtons. So certainly not a lot of thrust, but being able to have constant, truly infinite thrust is, or I guess truly limitless thrust, is a definite step change for the on-orbit operations and activities.
Thank you, fellow Earthlings, for joining us in our corner of the universe this week for the Space Times podcast. I've been Harrison Lambert, here with Paul Mayer. We hope you enjoyed this week's roundup of space news, and will join us again next week.